Hi everyone, welcome back. It's your math teacher, Mr. Boyden, and today we're continuing with our transformations unit. Today we're in 9-2 in the geometry book, and we're going to be learning about reflections. We probably already know a little bit about reflections. I'm assuming most of you looked in the mirror this morning. It's sometimes called mirroring, or if you flip a shape over. We mentioned that in unit 9.1, so let's get right into it and see what it is. Okay, first thing we need to know is this little bit of vocab, so include this in your notes, please. Okay, we need to know what a line of reflection is. That's specifically the line that we're flipping over. So in this case, we have a shape, and maybe you want to ask yourself which shape came first, the shape over here on the right in black or the shape over here on the left in blue. How can you tell which one came first? Well, look, that's C. That's C prime. What was first? Well, C was first. And then this is the line that it was flipped over. So this point went over to there, and this point B got flipped over to there. And then I want you to notice what's going on right in here. Remember these little markings and what they say. All that's saying is that this line, when you take the points, this point was some distance from that line. All it's doing is moving that same distance over to the other side. And that's going to be important today for the way we understand that. Same thing up here. C is some distance from the line. C prime is that same distance on the other side of the line. What about A? A is on the line, so it is 0 units away, and so now it's still 0 units away here. All right, now here's an example I want you to actually try. This is just still, we're kind of warming up our brain a little bit, making sure we understand the concept. So what I'd like you to do in your notes is exactly what the directions say. Draw the picture, then draw its image reflected across this line of reflection. And there's your line right there. And so what I'd like you to do is pause the video and try that now. Here's the image, flip it over, and see what that looks like. Now I'm going to try my best to draw it as well. So if you haven't paused your video, pause it now. Okay, and there's my attempt. It's not a very good job drawing, but I'm not very good at drawing. Here's what I'm looking for though. I want to see, do I really get the main concept? And so this point should have been flipped over to the other side. There it is. And this point should have been flipped over to the other side. And the distance from here to here should be about the same as here to there. It looks like I missed a little bit. It looks like this distance is a little bit less than that distance. So I'm a little bit off the mark, but I'm showing that I get the concept. The other thing is, this is kind of opening up to the left and pointing to the right. This one is opening up to the right and sort of pointing to the left. And these points are pointing right. These are pointing left. So it demonstrates that the shape flipped over to its other side. And that's what I want you to see in your drawing as well. Now let's get a little bit more base knowledge and we'll start getting into our questions. Okay, so we need to make sure before we get too far into this, we know how to graph different lines. Because yeah, we can use the x-axis and the y-axis as our lines of reflection, but they won't always work as our lines of reflection. And so we need to be able to graph things that look like these. So there's a little trick down here at the bottom that you can remember that'll help you. If it says x equals a number, like look at this first example, x equals 3. If it says x equals a number, that means that it is a vertical line. Now if you forget what that means, it means straight up and down. If it says y equals a number, like this example, y equals 4, that means it's a horizontal line. If you forget that, it's like the horizon. Horizon goes left and right. It's where the sun sets. So maybe the little sun is setting right there. Bye, little sun. See ya. And so now let's practice graphing these to make sure we understand how to do those. Why? Because both on the Smarter Balanced and on the test I'm going to give you, you're going to have to understand what these lines look like. And if you don't, you're not going to have much of a chance to be successful. So let's practice. Let's go over x equals 3. X equals a number means a vertical line. And so I'm going to go to where the x value is 3. That's 3 units to the right. 1, 2, 3. And so there's going to be a vertical line right here. And I'm going to do my best to draw it. And I'm not very good drawing on here yet, but I'm going to do my best, and you should be drawing this with me. And so there is my line, x equals 3. Okay, let's try another one. I'm actually going to use a drawing tool this time because I'm having the darndest time drawing with those. I want to do the next one, y equals 4, and so if I have a nice little drawing tool here, I think I'll use that. So y equals 4. Y equals 4 is a horizontal line at 4, so I'm going to count up 1, 2, 3, 4. And I'm going to put in a line. And I'm going to label them so I know which one is which, and that's y equals 4. And so what I'd like you to do now is pause the video. I want you to try to sketch these last two, and then you can unpause and see how you did. Okay, I'm going to keep going. Make sure you've paused the video. So x equals 1, that's going to be a vertical line, and that vertical line is going to be 1 unit to the right. So there's x equals 1. Y equals negative 2 is horizontal and down 2. So there it is, and I'll get these labeled up so you can see them here. And it's a good practice to label them. So y equals -2 and x equals 1. Okay, we're going to be reviewing this more and more throughout the lesson today, so you can see how to do these a little better. Okay, now let's actually start dealing with a point. Here we're given a point, 3, 2, and we are asked to do some reflections with it. So let's first of all, let's get our x and y axes on the page. Oops. So there's my x, there's my y. Please take the time to sketch this. The video is going to go quickly, but that's why you have a pause button. So pause it as you need to so you can be successful here. They asked us to graph a point at 3, 2, so I'm counting 3 to the right, up 2. And there's my point. I want to give it a name, and I'm going to put a B for Mr. Boyden. You can put any letter you want. It's totally fine. And here we go. We're going to answer some questions over here on the left. What are the coordinates of the image? So we have the pre-image. We're going to find the image if it's reflected across the x-axis. Okay, I'm going to label these. There's my x-axis. There's my y-axis. And so if I'm reflecting it across the x-axis, that's my line of reflection. It's going to flip down to there. And so here's the trick I like to use. I figure out how far away is this from my line of reflection. 1, 2. That means I'm going to count 1, 2 on the other side. And now I have B prime. Let's go back to the question. They asked for coordinates. Well, coordinates look like this, x and y. So we had to go, in order to get to this point, we go 1, 2, 3 to the right and down 2. So 3, -2. Now look at what changed. This was 3, 2. Our new point is 3, -2. When we flipped it across the x-axis, the point did not move to the left or to the right. It only moved down. And that's why the y value changed. That's the up and down value. And that's why the x value, the one that tells us about left and right, that's why that didn't change. That's still a 3, but this one became negative. In fact, that's what's always going to happen when you reflect over the x-axis. Your y value will become the opposite of what it was. Okay, so I've got my B prime. The coordinates, we need to now reflect them across the y-axis. Now, the question isn't totally clear, so what I'm going to do is I'm going to flip the original point B across the y-axis. So I'm going from here. I am going to change my color so we can see a little better. So B is going to flip across, so what am I going to do? I'm going to count to the line, 1, 2, 3, and then count 1, 2, 3 again. And so now it is that same distance on the other side of the line. Now, what are we going to name that point? We can call it B something. We got B prime. Let's go B double prime. Okay, and there we go. And the coordinates for that. How do we get there from the origin? Left 3, up 2. So -3, up 2. Now, that's the same thing as up here, except, look, it only moved left and right, and so our x value is what changed. It became the opposite. We had 3, now we have -3. The y value stayed the same because this point didn't go up and down at all. Now let's get into the ones that are just a touch more fun. And in order to do this, I'm going to have to actually graph the line x equals 1. So remember from a minute ago, look back in your notes if you need to, what does that line look like? I'd like you to actually pause the video and try to graph that line to see if you can remember what it is. And it's really, really good practice for you. So go ahead and pause the video and do that now. Okay, here's our line x equals 1. And we're going to reflect the point B across that line. Now, right in here, this gets confusing for a lot of people because there's 2 lines. You have to pretend like there's only one, only the line that the question asked about. This y-axis, it's there. That's going to be helpful for writing the coordinates. But while we do the reflection, pretend like the only line you see is x equals 1. So here we go. I'm going to count how far am I away from there. 1, 2, which means I'm going to go 1, 2 on the other side of it. And now I have B triple prime. Woohoo! Okay, we need coordinates of that. So now that we need coordinates, now we're going to look back at the y-axis. To get from the origin to our point, we go left 1, up 2. So -1, 2. And then finally, we need to do this one. So again, guys, I want you to pause the video and actually graph this on your own. I want to see if you can get y equals -1 graphed on your own. So pause now. And so here I've got it. Check mine against yours. That's y equals -1. And now we're going to reflect across that. So again, you're only looking at that line. So I'm going to reflect B across that. So 1, 2, 3 units away. 1, 2, 3 units away. Whatever it is on one side, it's the same on the other. And now I have b quadruple prime. Oh my goodness, that's getting way out of hand. Let's write our coordinates down. And one thing that helps me with this is if I re-identify where the origin is. Now notice, guys, all along the way I've been labeling everything. Y, x equals 1, x, y equals -1. One of the reasons that's important to do is so I can find the origin. The origin is where x and y meet, so that's the origin. And then what I have to figure out is how do I get from the origin to my new point. So 1, 2, 3 to the right, 1, 2, 3, 4 down. So I get 3, comma, -4. All right, let's do it this time with a triangle. Okay, and so we're going to be asked to reflect this across the line, x equals -4, and we've got our points of the triangle here. So why don't we take a minute and try to get this set up. First thing I'm going to do is I'm going to put down my axis. And so I've got my x and my y. I'm also going to put in the line x equals 4. You may want to pause and try that right now and make sure you understand how to do it. So 1, 2, 3, 4 to the right. And there is my line x equals 4, although you know what? I think I decided that I like dotted lines better. So I'm going to put in a dotted line. That way it's a little bit easier, hopefully, for me to tell which line is which. So 1, 2, 3, 4. And I want to label those up so I understand what I'm looking at. So the way I've done this, I've got the y-axis, I've got the x-axis, and I've got the line x equals 4. Now let's plot some points. 0, 3. And 2, 0, and 4, 2. So 1, 2, 3, 4, 1, 2. Wonderful. Cool. And I am all set. Now I want to connect those because it did say a triangle, and right now I just have 3 points. That's not really a triangle, and so I'm going to connect those with my best little drawing abilities here, which are not very good. And there's my triangle, and now it's time to do some reflecting. So guys, all this is going to be, it's the same thing we did a minute ago, it's just we have to do it 3 times because the triangle has 3 points. In our previous question, we only had 1 point, so this is going to take, I don't know, a moment longer, but it's not a big deal. Let's do one at a time. I'm going to start with this one. All I'm going to do is figure out how far is this from my line. I'm going to do the exact same thing on the other side. So 1, 2, 3, 4, which means I have to go another 1, 2, 3, 4. And there's my new point. Same thing down here. 1, 2, which means I have to go 1, 2. This is 0 units away, which means it's still 0 units away. It's kind of like hinging on that point. And so connect my dots. Okay, and there we go. Now, you should always double check. Does that look like the shape got flipped over that line? I mean, visually it should appear the same. The other question we would ask is this an isometric operation? Meaning, are these two shapes the same exact shape and the same exact size, just one of them's upside down? And yeah, it appears they are. This is kind of a weird bow tie or butterfly wing looking thing. So yeah, absolutely, we nailed it. Okay, now let's do another one, and we're going to have a little bit of review built into this one, so I think that will be sort of fun. So let's go ahead and start graphing our points. This one, the axes are given. Again, you're going to need to pause your video and write down the graph, write down the axis, all that. So I'm going to start graphing them. So I get 0, 1, that point is called x, and I get 2, 3, and that point is called y, and I get 4, 1, and that point is called z. And I've got my triangle. And now let's do a reflection. Now I left this one open-ended because I always like to pick a different number each time I teach this, just kind of for fun. It keeps things a little bit interesting. So why don't we do it over the line y equals -1. Would you pause the video and try to graph that, please? Because remember, we're practicing as we go, and by the end of this, you should be quite good at it. Okay, there's y equals -1. I would also suggest that you pause the video again and actually try to do this reflection on your own. If you make a mistake, so what? You're then going to get feedback from the video about how to do it correctly, and you're going to learn by making that mistake. Or you may find out that you totally know how to do this and you're already really good at it, and that would be a wonderful thing too. So I'm going to go ahead and start reflecting. So from here, I'm counting down to the line, 1, 2, count 2 more down to the other side. Boom, there's my new point. That is x prime. Let's count y. So 1, 2, 3, 4. Count 1, 2, 3, 4 more. And there's my new point, y prime. And then z down 1, 2. So down 1, 2. and now I've got my new shape. And now I've got z prime. Awesome. So number one, reflect xyz across the line y equals -1. Reflected it. Is it upside down? Is it the same shape? Yeah, my drawing skills are pretty bad, but it is the same shape. Now we're going to go to number two. Translate x prime, y prime, z prime. There we go. X prime, y prime, z prime. By the rule, xy maps onto x minus 6, y plus 2. And so what a great chance for us to review. Do you remember what the minus 6 does? Does that go up, down, right, or left? Remember, x is the left and right direction. Negative is that way, so that moves it to the left. Y plus 2, y is the up and down direction. Plus is positive, so that means it's going up 2. So I like to always write these down. So we're going left 6, and we're going up 2. Now all we're going to do, and I'm going to switch colors so it stands out a little easier, we just go point by point, and we do exactly what it says to do. So I'm going to go 6 to the left, 1, 2, 3, 4, 5, 6, and up 2. And there's my new point. Now, what do you think that point's going to be called? We need to give it a name. It came from z prime, so what's the image of z prime going to be? Z double prime. And we're just going to rinse and repeat with these other points. So 6 to the left, 2 up, 1, 2, 3, 4, 5, 6, up 2. There's my new point. That's x double prime. And we're going to do the same thing with y. 1, 2, 3, 4, 5, 6, up 2. And there we go. There's y double prime. And there we go. So we've done multiple translations in one. We're going to translate it to the left. We're going to translate it up. And does it look like the same shape, left and up? Yep. And notice it didn't rotate at all. It's still facing the same direction here. When we do a reflection, the direction the shape is facing changes, but in a translation it doesn't. So we've got some review and we've got some new all in the same question. Now, just a heads up, y'all, this is the way that it often gets tested. They do what's called a composition of transformations, meaning you're not just doing a reflection or a translation, but you're doing more than one. And they take turns. You don't do them simultaneously. You do one and then the other, but that's a really normal thing that comes up, especially on tests and on SBAC, so be looking for that. Okay, and we're going to do one more just for practice, and then we'll be done today. So we're going to do a little bit of graphing first. Let's graph those points, x, y, and z. Take a minute to do that. I would suggest you pause the video and practice, because that's the only way you're going to get better is if you're actually doing the practice on your own as well. So 0, 1, I'm going to call that x, 1, 2, 3, 4, 5. Okay, and there's my little triangle. Glorious. Okay. And we're going to be doing so we're doing a reflection. We're going to have to make up what that is, and then we're going to translate x prime, y prime, z prime. And let's make sure we understand what this is before we get too far into it. X has nothing going on with it, so that means no slide left and right. Y minus 4 means we're going to go down 4. And so I've already labeled that. So let's pick one that looks a little visually challenging. One that I think would be visually challenging on this is if I picked x to be 2. And so go ahead and sketch that in. And the reason I'm doing that is I just want to show you one more thing that can happen on this last example. Visually, it can be confusing for people, and so we want to practice that. Okay, so we've got our line. I'm going to label it as x equals 2. And now we're going to do our reflection. And so no matter how good or bad the picture looks, stick with the rules that you know. We know that we take any point, we see how far it is from the line, and we do the same thing on the other side. So this is 2 units away. I'm going to go 2 units on this side, and I'm going to put the point and call it x prime. I'm going to do the same thing with y. 1, 2, 3, 1, 2, 3. 3 units away on the left side, and that's y prime. And then I'm going to do the same thing with z. Z is 1 unit away, so I'm going to go 1 unit onto the other side, and that now is z prime. And the reason this sometimes can confuse people is because now these shapes are overlapping. It moved the shape, it flipped the shape, but they still are over top of one another. So it's like flipping a puzzle piece but not moving it left and right. We kind of flipped it almost exactly right where it was. That's okay. That's not a problem at all. It's something that comes up, and it actually can come up with some cool looking designs, so that's a good thing. Okay, so now we're going to do this next part, translate this function by the rule, or this triangle, x prime, y prime, z prime, by the rule, and we've already annotated what the rule means, so it's going to be pretty easy. Just slide all the points down 4. So I'm going to take y prime down 1, 2, 3, 4, and there's y double prime, and take x down 1, 2, 3, 4, and there's x double prime, and then let's take z, and we're going to go down 1, 2, 3, 4, and there is z double prime, and holy moly, now these shapes are really overlapping. And that's okay, not a problem, it happens. One thing, ooh, that was not good, let me try again. Uh-oh, I'm struggling here. Okay, so one thing we always want to check on these, since these are what's called a rigid motion, meaning the size doesn't change, we want to make sure the shape didn't change shape or size. So do all these triangles look congruent? The answer should be yes. And folks, there's some issues with my drawing skills on this little tablet I'm writing on. And so, yeah, there's a little bit of goofiness happening right in here. But in general, with where the points are at, do these triangles appear to be the same triangle? Yeah, they do. And if they aren't, that means you made a mistake. The most common error that people make is they make a mistake counting. They go to count down 1, 2, 3, 4, and they accidentally count down 5 or something like that. So if you find that your shapes look like the type of shape changed, or if they have different proportions, like different side lengths, then you want to double check your counting, because that's almost definitely where your mistake is at. We're going to be including dilations in these later, and so then the size will change, but that'll create a similar shape and all of the proportions will still be intact. That's all for today. Hope you enjoyed the video and hopefully that helps you with your assignment, and we'll see you next time. Bye!